There are few places on Earth where you can actually watch the planet change shape. But when lava reaches the ocean, that is exactly what happens. Sometimes the water explodes into clouds of acid and volcanic glass. Sometimes entire coastlines move. And sometimes, where there was once nothing but open sea, new land begins to appear. These are 10 real moments when lava reached the ocean, and the shoreline was never the same again. Number 10. Kilauea, Kapoho, Hawaii, 1960. On January 15, 1960, the coastline of Hawaii began moving. Not because of tides, erosion, or an earthquake, because molten rock was pushing the island farther into the Pacific. 2 days earlier, a new eruption had broken open Kilauea's lower east rift zone near the village of Kapoho. Lava fountains rose above the fissures, while thick aa flows began moving northeast, consuming vegetation and spreading toward the coast. The ocean was only 3.2 kilometers away. The lava reached it on January 15th. But the Pacific did not simply extinguish the flow. As molten lava entered the water, its outer surface cooled and shattered, while fresh lava continued arriving from behind. Layer after layer accumulated along the submerged slope, gradually giving the flow something solid enough to build upon. And within hours, something remarkable happened. By the end of that first day, the new shoreline extended roughly 100 meters beyond the coastline that had existed that morning. The eruption kept going. For more than a month, lava continued reshaping the eastern edge of Hawaii. Attempts were even made to redirect some of the flows with barriers, but sections of Kapoho were eventually overwhelmed. When the eruption finally ended on February 19th, more than 10 square kilometers had been covered by lava. About 2 square kilometers of that was entirely new land, ground that had previously been part of the Pacific Ocean. Kilauea had not simply reached the sea. For a brief moment in 1960, people were watching Hawaii build itself in real time. Number 9. Teneguia, La Palma, 1971. At first, it was only a red glow on the southern tip of La Palma. Then the glow began moving toward the Atlantic. On October 26, 1971, after several days of small earthquakes, fissures opened near the southern end of the island. Gas and volcanic fragments burst from the ground, and within hours, 3 main vents were producing lava fountains. 2 major lava flows formed almost immediately, and both were heading downhill. La Palma's steep volcanic slopes gave the lava a direct path toward the coast. By October 28, observers were already reporting that the flows had reached the sea at the southern tip of the island. But the eruption was only beginning. Over the following weeks, new vents opened along the fissure. Some produced fountains of glowing fragments hundreds of meters into the air. Others released thick, blocky lava that advanced slowly across the black volcanic landscape. Eventually, as many as 6 eruptive centers were active during the 3-week event. Again and again, lava reached the coastline. On October 31st, flows spilled over the sea cliffs east of the Fuencaliente lighthouse. A few days later, enormous quantities of lava were reported running from the western cliffs directly into the Atlantic. Each contact transformed the edge of the island. The ocean cooled the outer surface of the lava, but fresh molten rock kept arriving from behind. Instead of disappearing beneath the waves, the flows accumulated along the coast and began forming new platforms of volcanic land. Smithsonian reports from the eruption specifically recorded one of these new coastal platforms. By the time the eruption ended in November, a new volcanic cone, Teneguia, stood above the landscape, and the southern coastline of La Palma had been permanently altered. And 50 years later, the island would experience the same terrifying process again, on a much larger scale. But in 1971, cameras had already captured the warning. On La Palma, even the coastline was temporary.
Number 8. Stromboli, Italy, 2002.
The lava did not take days to reach the Mediterranean. It took about 30 minutes. On December 28, 2002, activity at Stromboli suddenly intensified when a new lava flow began descending the volcano's northwest flank along the Schiara del Fuoco, a steep, collapse-scarred slope that acts almost like a natural chute toward the sea. From the vent to the shoreline was only about 1 kilometer. Gravity did the rest. The lava moved rapidly downhill, splitting into channels as it crossed the dark volcanic slope. Within roughly half an hour, it had reached the Mediterranean and formed a glowing front hundreds of meters wide along the coast. But that was not the most dangerous part. As lava continued pouring toward the water, the steep flank above it became increasingly unstable. 2 days later, a major section of the Schiara del Fuoco collapsed into the sea. The impact displaced an enormous volume of water. A tsunami followed. Waves several meters high struck parts of Stromboli's coastline, damaging buildings and boats and forcing residents away from the shore. Suddenly, the eruption had changed character. The threat was no longer only molten rock coming down the mountain. It was the mountain itself falling into the ocean. That is what makes Stromboli's 2002 eruption so different from most lava entry events. The lava reached the sea in minutes, but the sea sent the danger straight back toward the island.
Number 7. Stromboli, Italy, 2007.
5 years after Stromboli sent lava racing into the Mediterranean, the volcano found another route to the sea. On February 27, 2007, a new fissure opened high on the northeastern side of the active crater area. Almost immediately, lava spilled onto the Schiara del Fuoco, the enormous scar that cuts down Stromboli's northwest flank directly toward the coastline. Then the flow divided. 3 separate branches began descending the steep slope, glowing against the black volcanic rock as gravity pulled them toward the Mediterranean. They reached the sea rapidly, but unlike the brief surge seen in 2002, this eruption kept reorganizing itself. By the end of the first day, the original flows were fading when another vent opened much lower on the volcano at roughly 400 meters elevation. That changed everything. Now the lava had a shorter journey to the water. For days, the new vent continued feeding molten rock down the Schiara del Fuoco. 2 major branches reached the shoreline, producing steam plumes where lava met seawater. And slowly, the edge of Stromboli began moving outward. So much lava accumulated at the base of the slope that it created a new lava bench, tens of meters wide, significantly altering the coastline. Even when one vent stopped, another could open higher up and begin feeding the sea again. That is what makes Stromboli so unusual. The Schiara del Fuoco is not simply a volcanic slope. It acts like a natural corridor, funneling lava, falling debris, and other eruptive material from the summit toward the Mediterranean. In 2007, the lava did not merely reach the ocean, it used the volcano's own geography to redraw the edge of the island.
Number 6. Mauna Loa, Hawaii, 1950.
On the night of June 1st, 1950, people living on the western side of Hawaii did not have days to prepare. Some of them had only hours. At 9:04 p.m., a fissure opened high on Mauna Loa's southwest rift zone. Within minutes, lava fountains were roaring so loudly they could reportedly be heard from nearly 24 kilometers away. Then, the lava started downhill. Mauna Loa's western flank is unusually dangerous because it combines steep slopes with a relatively short distance between the rift zone and the ocean. Once a high-volume eruption begins there, gravity can turn a lava flow into a race against the clock. That night, one flow won that race frighteningly fast. By 12:30 a.m., Aa lava had crossed Highway 11 near Pahoehoe, destroying a gas station, the post office, and several homes. Just 35 minutes later, at 1:05 a.m., it entered the Pacific. The lava had traveled roughly 24 kilometers from its vent to the ocean in less than 3 hours. And when it hit the water, the coastline disappeared behind steam. Billowing clouds rose as high as 10,000 feet, more than 3 kilometers above the ocean. But the most frightening part was what had happened before the lava ever reached the sea. The flow had crossed the main highway, entered a coastal village, and cut through the route people depended on to escape. Everyone made it to safety, but USGS later described some of those escapes as extremely close. The eruption continued for 23 days and released roughly 376 million cubic meters of lava. Several separate flows eventually reached the ocean, while around 24 structures were destroyed. Mauna Loa had demonstrated something that still defines the volcano's danger today. Sometimes the question is not whether the lava will reach the ocean. It is whether anything in between can get out of the way fast enough.
Number 5. Piton de la Fournaise, Réunion, 2007.
On April 2, 2007, lava broke from the southeastern flank of Piton de la Fournaise and began moving toward the Indian Ocean. By the end of the same day, it was already there. But reaching the sea was only the beginning. The eruption accelerated dramatically. Scientists estimated the lava discharge at around 100 cubic meters per second, an extraordinary rate for Réunion, not seen there for decades. Lava fountains climbed roughly 100 meters above the vents, while broad rivers of molten rock spread across the Grand Brûlé. At the coastline, the encounter became violent. As lava entered the Indian Ocean, explosions shattered the cooling rock. Fine volcanic particles and strands of Pele's hair were carried kilometers away, while fragments of basalt fell across the surrounding area. And still more lava kept coming. Flows continued reaching the ocean through April, sometimes traveling through lava tubes before emerging near the coast. Large steam plumes rose from the shoreline as molten rock continued piling into the sea. Then something much larger happened beneath the summit. As enormous volumes of magma drained away, the floor of Dolomieu crater began collapsing. Within days, an area roughly 1 kilometer across dropped hundreds of meters downward. Later measurements showed that much of the crater floor had fallen about 330 meters, radically changing the summit of the volcano. By the end of the eruption, scientists estimated that roughly 100 to 140 million cubic meters of lava had been released, making it one of Piton de la Fournaise's most voluminous eruptions of modern times. Much of that material had disappeared into the Indian Ocean, where it built a large new coastal platform. The spectacle at the shoreline was enormous. But the real scale of the eruption could only be understood by looking in 2 directions at once. While lava was building new land at the bottom of the volcano, the summit itself was collapsing hundreds of meters above it.
Number 4. Eldfell, Heimaey, Iceland, 1973.
Just before 2 a.m. on January 23, 1973, the ground split open beside the town of Heimaey. Within hours, fountains of lava were rising from a fissure nearly 2 kilometers long. The eruption could hardly have happened in a worse place. Heimaey was home to thousands of people, and its harbor was the economic lifeline of the island. Fishing boats depended on that narrow entrance, and almost everything the community needed moved through it. Then the lava began advancing toward the sea. As the eruption continued, a growing wall of molten rock moved across the eastern side of the island and threatened to squeeze the harbor entrance shut. If that happened, the eruption would not just destroy buildings, it could cripple the town's future. So the residents tried something extraordinary.
they decided to cool the lava with the ocean itself. At first, crews used pumps from local fire engines and fishing vessels. Later, much larger pumping systems were brought in, sending huge quantities of seawater through pipes directly onto the advancing flow. The idea was simple, even if the scale was not. Cool the surface, thicken the lava, slow it down before it could block the harbour. For weeks, workers operated in conditions few engineering crews had ever faced, standing near glowing lava, moving pipes as the ground changed beneath them, and constantly trying to stay ahead of a volcanic landscape that refused to remain still. Millions of tons of seawater were eventually pumped onto the lava, and the harbour survived. The eruption still transformed Heimaey. Homes were buried, the coastline shifted, and a new volcanic cone, Eldfell, rose beside the town. But the lava that threatened to close the harbour never completed the job. In Heimaey, people did not simply watch lava reach the ocean. They used the ocean to fight back.
Number 3. Surtsey, Iceland, 1963. This time, there was no coastline for the lava to reach. The eruption began beneath the ocean itself. In November 1963, volcanic activity broke through the seafloor south of Iceland. At first, seawater covered everything happening below. Then, explosions began reaching the surface. Ash, steam, and fragments of volcanic rock burst upward as rising magma met cold seawater. The interaction was violent enough to build material faster than the waves could immediately wash it away. And then something extraordinary appeared. Land. A dark volcanic island began rising out of the North Atlantic, where only days earlier there had been open water. It was named Surtsey. But appearing above the ocean was only half the battle. Fresh volcanic ash and loose fragments are extremely vulnerable to waves. Several nearby islands created during the same eruptive episode eventually disappeared beneath the sea because erosion destroyed them. Surtsey survived because the eruption changed. In 1964, lava began flowing across the young island. Unlike the loose ash beneath it, the cooling basalt formed a much harder, protective surface. Lava continued entering the surrounding water, gradually armoring parts of the island against the Atlantic. The eruption continued, on and off, until June 1967. By then, Surtsey was no longer a temporary pile of volcanic debris. It was a real island. And scientists immediately realized they had been given something almost impossible to recreate. An untouched piece of land whose biological history could be observed from the very beginning. The island was protected, allowing researchers to watch seeds arrive, plants establish themselves, birds appear, and ecosystems gradually develop on land that had never existed before 1963. Most eruptions in this countdown show what happens when lava reaches the ocean. Surtsey showed something far stranger. Here, fire met the sea, and an entirely new piece of earth emerged between them.
Number 2. Cumbre Vieja, La Palma, 2021. The Atlantic was always downhill. The real question was how much the lava would destroy before it got there. On September 19, 2021, an eruption began on the western side of La Palma in Spain's Canary Islands. Fissures opened along the Cumbre Vieja volcanic ridge, and within hours, lava was moving through populated areas below. Unlike many eruptions where lava crosses empty volcanic terrain, this flow had communities in its path. Homes, roads, banana plantations, power lines, entire neighborhoods. The lava moved slowly enough for people to evacuate, but not slowly enough to save everything it touched. For more than a week, the world watched the glowing front move steadily westward. Every kilometer brought it closer to the Atlantic. Then, late on September 28th, The lava finally reached the coast near Playa Nueva and began pouring over the cliffs into the ocean. From a distance, it looked almost unreal. Bright rivers of molten rock disappeared into black water, while huge white plumes rose above the shoreline. But those clouds were not ordinary steam. When extremely hot lava reacts with seawater, it can generate acidic vapor and tiny particles of volcanic glass, a hazardous mixture often called lays. Authorities warned people to stay away from the coastline. And still, the lava kept coming. As more material entered the Atlantic, it began accumulating faster than the waves could remove it. A new lava delta formed. The coastline started moving outward. By the time the eruption officially ended in December, lava had covered more than 12 square kilometers of La Palma and destroyed thousands of buildings. Several lava deltas had also added new land to the island's western coast. That creates one of the strangest contradictions of the entire eruption. The same lava that erased homes, roads, and familiar landscapes was simultaneously making the island larger. By the time Cumbre Vieja stopped, the Atlantic coastline people had known before September 2021 no longer existed.
Number 1. Kilauea, Hawaii, 2018. When Kilauea's lava finally reached the Pacific in 2018, the ocean did not end the danger. It created a new one. The eruption had begun weeks earlier along Hawaii's lower East Rift Zone, but one vent, Fissure 8, eventually became dominant, feeding a fast-moving river of lava through a channel that stretched more than 12 kilometers toward the coast. Everything between the vent and the ocean was now in its path. Roads disappeared. Homes were surrounded or destroyed. Entire sections of the landscape were buried beneath fresh basalt. Then, on June 3rd, the lava reached Kapoho Bay and entered the Pacific. From the air, the scene looked almost impossible. Orange lava poured into dark seawater, while enormous white clouds rose from the coastline. But those clouds were not harmless steam. The interaction between seawater and intensely hot lava produced what volcanologists call lays, a mixture containing steam, hydrochloric acid, and tiny particles of volcanic glass, capable of irritating the lungs, eyes, and skin. So even after the lava reached the ocean, people still had to stay away. And the lava kept coming. Within only 3 days of the first ocean entry, Kapoho Bay had been completely filled. Where boats once crossed open water, there was now black volcanic rock. The new lava delta extended more than a mile beyond parts of the former shoreline. By June 12th, roughly 250 acres of new land had already been added to Hawaii. Days later, that figure continued growing as Fissure 8 kept feeding lava into the Pacific. But even this new ground carried another danger. A lava delta can look solid from above while resting on unstable piles of fragmented rock underwater. Parts of it can collapse suddenly into the sea. That is what made Kilauea's 2018 ocean entry so extraordinary. Every stage created another consequence. The eruption destroyed old land. The ocean created toxic lays. And then the same lava that erased neighborhoods began extending the island itself. In 2018, cameras captured one of the strangest contradictions on Earth. Hawaii was being destroyed and created at exactly the same time.
The ocean may look like the end of a lava flow, but as these eruptions showed, sometimes it is only the beginning of another transformation. Coastlines move, new land appears, and entire landscapes can be rewritten in a matter of days. Which of these eruptions surprised you the most? Let me know in the comments. And if you want to see more real moments when Earth changes right in front of the camera, subscribe and keep watching. I'll see you
in the next one.